Good morning, professors. I welcome you all to our second session of today's FPTP. I welcome Dr. Usha Devi, ma'am, as a resource person again. I welcome you, ma'am. And we can start the session.
Okay, thank you, ma'am.
Thank
And
you.
then, sir, good morning, all. So, today's topic is about sorting, and then, okay, so everyone knows about it. And then, starting, um, sorting is an unordered collection. So, initially, we have an unordered collection that we are trying to make it as an ordered one. Okay, what it could be either in the ascending order or descending order. Sometimes, in case of strings, and then we can say it about alphabetical order or a reverse alphabetical order. Okay, and that's all. So this one we are going to concentrate on numbers. Therefore, we need to either do it in the ascending order or descending order. So initially it will be in the unordered collection that we are making into an ordered collection. Just to see here, there are 6 different numbers and then so 77, 42, 35, 12, 101 and 51. So these things and then we are trying to make it as an ordered one. Ordered one means and then so from smallest to highest or highest to smallest and then so. So whichever you require and then so that we can do it. Then this is an example initially and then it could be in the unordered collection. So finally it will be in the ordered one and then so. So what kind of ordering is followed? What kind of ordering is followed here? Is it an ascending or descending? Yes, please be interactive. According to this example, is it an ascending order or descending order? Am I audible?
Yes, ma'am, you are audible.
But there is no response.
Sorry, ma'am.
Yes, what is this order? Ascending or descending? Okay, from smallest to highest, we are making into the order. Okay, so that is called as ascending order. So your final output becomes here ascending order. All the 6 elements should be sorted in this manner. So there are lots of sorts are available. Now I am going to concentrate on these 3 sorts sorting methods. One is the bubble sort, next one is an insertion sort, and then third one is selection sort. We'll see one by one. I'll start with bubble sort. Okay, the name itself is bubble. Okay, and then so which one is the largest one that will always in the topmost stage and then so that you are trying to identify in the collection of items, then that you have to put it in any one end. Okay, that is the meaning here. And then so you are bubbling up the largest element and then that you are move it to one end. And then, so that and then either you can make it as an ascending order. In case of ascending order, that you are trying to move it to the right, or in case of descending order, that you are trying to make it at move it to the left end. Okay, so depends on which order you require, and then we are trying to find it out. Okay, so you are keep on doing the repeating the same process. Okay, so that we can call it as an iteration here. Then okay, at each iteration, you are doing certain number of steps. Then after finally, you are going to get it in the ordered form. Okay, and then so just see here, we are going to trying to bubbling up the largest element. So it has some collection of elements. There are same 6 set of elements are available. Then what you have to do? So you are trying to bubble the largest value, okay, to the end. Okay, so how you are trying to do that? Then so you can have a pairwise comparison. Okay, and then so for example, first we are going to start from the first element. Okay, shown the step by step. Okay, so first we are trying to start from the first element, that you can pair it with the second element. So therefore the pair here is 77 and 42. Okay, so you have to take these 2 elements and do the comparison. Okay, so that is called as pairwise comparison. So what you are going to do? you need to identify the largest element in that pair. Okay, so within this, which is the largest element within this pair? I have taken the first pair. It contains two elements, 77 and 42. Among that, and then I have to find out the largest element. Okay, so that is the concept here. Okay, and then, so 77 is the largest element. And then, so if the first element is the largest element, then what you have to do, that you need to move it to the end within that pair itself. Okay, so what you have to do, you need to do the swapping process. After the swapping process, and then what happens? And then the highest element will be moved to the right end. Okay, and then so then one step process is over. Okay, next you can go for the second step. So within that, then you are going to pick the next element. Then that you are going to make it as a pair with the previous element. So now the pair is 77 and 35. Again, do the pairwise comparison. Okay, so if the first element is the largest one, just make a swap. Okay, if not, just leave it. Okay, so now which is the highest one? 77, the first element. In such case, you are trying to swap it. Okay, so that should be in the second step. Now, 77 moves to the third place. Okay, and then the second step is over. Next, move on to the next step. Then take a next element, that is fourth element, make a pair with the third element, then again do the pairwise comparison. Okay, and then so the largest element here is 77 again. Okay, therefore you have to do the swapping process. Okay, after swapping, that will be moved to the right end. Okay, and then again you are going to take the next element. Okay, make a pair with the previous one. Now, okay, so which is the highest element? Okay, this one, the second element itself is the highest element. Therefore, no need of any swapping. Okay, so that's why it is mentioned here. Okay, there is no swapping process. Just leave it as it is. Okay, and then so this step is over. Next, move on to the next step. Okay, again, make a pair, and then which is the highest element? If it is the left one, then do the swapping, move it to the right. Okay, and then so this process has to be done till the end of your number. That it means and then the last number. Okay, and then so now everything was over. Okay, so at the final, okay, that is after how many steps? So first one we have done 1, 2, 3, 4, 5. Okay, after 5 steps, and then the one number could be placed in a proper place. Okay, the highest number from the list is to be identified, and that we are going to kept it in the right end. So that is the meaning here. So this is called one iteration. Okay, so all these steps under, okay, this part is with one iteration. Okay, similar to that, and then you have to, now it is properly placed, therefore leave the last place. Then rest of the numbers, and then you have to consider it again. Okay, now the array size will be considered up to 5 alone. It means and then totally 5 numbers. Okay, now the same process or iteration of steps has to be repeated for the first 5 numbers. Okay, since and then the last number is placed at the first iteration itself. During the second iteration, okay, second highest number is to be placed at its okay, position. Similarly, you can go for a third iteration. Okay, that the third largest number has to be placed it at the okay, end of the iteration. Similarly, fourth iteration, and then you are going to place the fourth largest number. Again, fifth largest, and then okay, sixth largest number. So therefore, and then all these numbers are properly placed okay in their positions. Okay, we will get the finally ordered element like that, and then so which is the highest one, then you are going to take it, and then you have to place it in the proper place. And then, okay, that is called as your bubbling process. And then so. Then the first iteration I have shown. Similarly, you can go for repeating the same set of process for the next iteration that I have written like this. Okay, and then so. The next iteration, the fifth element has to be place it in the proper order. Okay, how many number of steps are required for each iteration according to these numbers? 6 numbers. According to these example, how many number of steps in the first iteration is required? Yes, answer please. How many comparison we made for 6 numbers? 5 comparison. Okay, first pair, 1 comparison. Again, second pair, second one. Then third pair, third comparison. Fourth one, and then fifth one. If you have 6 numbers, you are going to have 5 comparisons.
Ma'am,
Yes,
sorry to interrupt. Slide is not moving.
slide is
Still in the first page. Okay, okay, ma'am. Now fine, ma'am. Thank you.
okay, okay.
Okay.
Oh, I put it in the full screen mode. Yeah, these are the things I have shown. This is the initial stage. After that, and then so I'm taking the first pair, 42 and 77. Okay. Then again, the second pair, which is the highest one, that you move it to the right. Then do the third comparison, third pair. Okay. And then again, find the highest number, that move it to the right. Then next one, next pair, that is fourth pair. And then already it is in order. Okay, since highest is in the right end, and then so therefore no need of swapping. Okay, then move on to the next step, and then the last pair. Okay, 5 1 1 0 1. Then so what you have to do? Okay, so here also there is no need of any swapping, and then directly you are going to place it in the proper place. So this could be the largest. So how many number of comparisons made? How many comparisons are made? Yes. How many comparisons are made? If you have 6 numbers, what I said, the first comparison is about first pair. Then again, 2 and 3, second pair. 3 and 4, third pair. 4 and 5, fourth pair. And then 5 and 6, fifth pair. So there are 5 different comparisons. After fifth comparison, you are going to place the largest number in its proper place. It means on the right end. Okay, so now the iteration 1 is over. Okay, this is the first iteration. Next, you can go for second iteration. So during the second iteration, we are not going to consider the last element. Only the first 5 are going to be taken. The same set of steps has to be repeated. Okay, so how many number of times this is done? N minus 1 comparison. So here n minus 2 comparisons. After n minus 2 comparisons, the second iteration will be over, and then the second largest to be placed in its proper place. Then in case of third iteration, so just leave the last two, then we are going to consider the first 4 numbers alone. Okay, at the end of the third iteration, okay, and then so the third number, third largest number has to be put it in a proper place. Okay, and then so therefore how many comparisons are required here? N minus 1, n minus 2, n minus 3, here n minus 4. So this is a fourth iteration. Then n minus 5. Okay, so this is our fifth iterations. Okay, and then so how many iterations you have to do? If you have 6 numbers, 5 iterations. Okay, and then so there are 5 different iterations we have to do, and then so that is n minus 1 number of iterations we have. Okay, and then hmm, so totally how many number of comparisons altogether in a single iteration? How many comparisons in a single iteration? How many number of comparisons according to this number? Yes. So if it is n minus 1 comparisons are required. Then how many number of iterations? Okay, the same thing has to be repeated n minus 1 times. Okay, at every time, and then it is going to be reduced once. Okay, the number of comparison will be reduced to 1. And then, so based on this, and then we are going to calculate the complexity of the algorithms. And then first we will see the algorithm, then what should be the complexity. Okay, and then so these are the steps or procedure to follow it in our bubble sorting algorithm. And then okay, so what you have to do, and then we are trying to do it with n minus 1 time alone. Then there are 2 loops. Okay, so one is for number of iterations, and then okay, and then so this is the outer loop, and then this one, how many number of steps you have to do it within the iteration. Okay, that is given here. And then so that is to do here. Okay, and then if 2 is 0, then you are going to come out of the loop here. Okay, and then so when do you go for a comparison? The first value is compared with the second one. Okay, this one is the highest one. Then you can go for swapping process. Okay, swapping means just simply an exchange. So that is written here. So this is very, very important. And then so when you are going to do the swapping process, so just to compare the pair. Okay, so the pair is indicated here as A of index. Then the second value in the pair is index plus 1. Okay, those two values has to be compared. And then if so, if it is greater, then you can go for swapping. Otherwise, and then you move on to the next number. Okay, like that. And then the pairwise comparison within the iteration is done under inner loop. Okay, and then so once completed, how many iterations you have to do, that should be decided by this to do. Okay, and then that depends on the number. Okay, and then so that you are trying to reduce it to 1, and then so that specifies the outer loop. And then so this is the algorithm or procedure, and then so which is followed for bubble sorting. Mhm. Suppose there are so many questions, and then if the given data itself is already ordered, and then what to do, how many number of times to be repeated, even that, and then so you can go for so many number of comparisons, but there is no swapping process. Okay, and then so just see here, then so many iterations you have to do, but okay, so always it has to do a comparison. If it is always highest, therefore, and then what happens, that is the second number is always highest, therefore though there is no swapping. Okay, only this statement alone will not be executed. Rest all steps will be continued, and then okay, and then so while you are comparing, it is always highest. Therefore, there is no swapping. Only swapping alone can be eliminated at this state, and then if it is already in the sorted order. Okay, and then so that is a question for this one. Then based on this, okay, totally at the maximum, the order of n squared. Okay, that should be the time complexity for it. And then, okay, so how many number of comparisons? N minus 1. If you have n numbers, then how many number of iterations? Okay, that also n minus 1. Okay, I told here. Okay, and then so n minus 1 into n minus 1. Okay, n minus 1 the whole square, that we can return in the form of order of n squared. That should be the time complexity. Okay, how much time is taken for that, and then this is for recurring the space complexity. Okay, so it is always 1, and then so there is any swapping, then alone, and then so it can take place. Then that will be treated as one here. Okay, and then so that's all about bubble sorting algorithm. Where do you use such kind of sorting algorithm? This is the very simplest one, then easy to implement. Just simple functions alone we are doing. One is the comparison, that is finding the maximum one. Okay, and then so another processing is simply swapping. Okay, sometimes you have to do swapping. Okay, otherwise, okay, we are not going to do such kind of swapping process. That depends on the maximum element present in its position. Any doubts about this? Yes. Any doubts? Okay. We'll move on to the next one. It is a selection sort. Okay, and then it's also similar kind of bubble sort, and then okay there, and then we are trying to find the largest number. Okay, that always bubbles. Okay, so at the top, then in case of this one, the processing is somewhat different, and then okay, here also we are trying to find the largest amount element or a smallest one, and then so in all the cases, and then so we have two kinds of implementation. Either you can make it as an okay ascending order or descending order. So based on that, and then we are trying to okay change the process, simple process alone, and then in case of selection sort, okay, and then mm, here we are going to divide the list into two. One is sorted, another one is unsorted. And then, okay, so that is given here. Sorted part that is always available at the left side, and then unsorted part at the right end. And then okay, and then so initially we may not know whether the numbers are sorted or not, and then so that sorted part is empty. Then all the elements are present in the unsorted part. Okay, this is the initial stage. Therefore, okay, sorted part is empty, and then unsorted part is having the entire list. Then so you can go for two ways of implementation. So one is the I said, and then smallest element is selected from the unsorted array. Since and then initially all the elements are present at the in the unsorted part. Okay, therefore, among this, then you are trying to find only the smallest element and swapped with the leftmost element. Okay, if it is an ascending order, then that you are going to place it at the okay leftmost element. Okay, that comes to the sorted array. Then another kind of implementation is okay. So instead of finding the smallest element, you may have a largest element. Okay, that you need to select it from the unsorted part. Okay, and then that you are move it to the rightmost element. Okay, so these are the two ways of implementation, which one is required, and then so based on that, and then you can frame an algorithm. Then so like this, and then so keep on repeating the same process, and then so till all the unsorted parts of elements goes to the sorted part, and then okay, and then so based on this, and then the number of times, and then we are trying to do is also similar to your bubble algorithm, and then so n into n. Okay, it's a average or worst case complexity, which is of n squared. Then if you have n number of items, okay, so I have given with some example. It is also having some animation. Mm, mm. How many elements are here? Again, there are 6 elements. Okay, so I make it into three different colors. While you are doing the comparison, okay, so which are the elements you are going to make a comparison, that will be in the yellow color. Okay, if you are trying to move, okay, then that will be in the green color. So once it is finalized, it is placed in the proper order. Okay, it means and then it is in the sorted order, then that will be in blue color. Okay, and then so always and then we are going to take the first number. Okay, so now this number will be taken for a comparison. Okay, so now it is in yellow color, and then the next for a next number you are going to take it for a comparison is 1. Okay, then again the third number, fourth number, fifth number, and sixth number. Among this, what you have to do, I said, and then either you need to find the largest one or smallest one. Okay, so according to this algorithm, okay, this example, I am going to find the largest one in the list. Okay, and then so in order to do that, and then how many comparisons I made? First, I have taken first number that you have to compare it with the second one. Okay, so I'm checking which is the largest one, 5. Then similarly, next one, okay, again 5 is the largest. Okay, so again one more comparison. So 4 and 5, again 5 is the highest. Then the next highest is 6 here. Then again, okay, one more comparison. Okay, so even that in the last comparison, 6 is the highest one or largest one. Okay, and then so after n minus 1 comparison, we are trying to find out the highest number in the list. Okay, so now 6 is the highest number that I am going to swap it or move it to the last position. Okay, so the last position here is, okay, this one's 2's position. So therefore, those two numbers could be swapped. Okay, and then so now this is called a first iteration. Okay, after the first iteration, the largest number will be place it at the proper position. Okay, and then mm. then the same set of steps has to be repeated for rest all numbers. Okay, now these are the numbers in the unsorted array. This is under sorted array. Okay, and then so in the second iteration, there are 5 numbers in the unsorted array, only one number in the sorted position. Okay, and then then next the same thing has to be repeated for unsorted list. Then again start from the comparison. Okay, start from the initial number onwards. Okay, so 1 and 5, which is the highest? 5 is the highest. Again compare it with 3. Now again 5 is the highest one. Then okay, we compare with 4, and again 5 is the highest one. Again compare it with 2. So again 5 is the highest number. So now uh, at the end of the iteration 2, 5 is the largest number. So that you have to swap it to, okay, so n minus 1 position. Okay, now those two numbers have to be swapped. Okay, and then so these are the steps falls under their second iteration. Okay, and then now at the end of the second iteration, second largest number is placed at its proper position. Okay, just leave these two. Okay, these two are under sorted list, and then the rest of the numbers are in unsorted form, unsorted list. Okay, and then now you have to take and then these 4 numbers in the unsorted array. Again, repeat the same step. Okay, now third iteration starts, and then so again you have to start from the first, compare it with the second element. Okay, so now the highest element is 2 alone. Then again compare it with 3. So now the highest element is 3. Compare it with the next element 4. The largest number is 4 alone. Okay, and then this number as well as, okay, so it is already in its proper place. Therefore, and then no need of swapping. Okay, just leave it as it is. Now, sorted list contains 3 elements. Unsorted list contains 3 elements. Okay, and then again the next fourth iteration starts. Okay, and then find out the largest number. Now 3 is the largest number. So already it is in its place itself, and then there is no need of data movement. Okay, and then just 3 is placed in its place itself. And then so now unsorted list contains four, and then sorry, sorted list contains four elements, unsorted list contains two elements. Okay, and then so again the same fifth iteration starts. Okay. Mm. Then 2 is the largest one, therefore okay, you can have a data moment and then okay, swap it and then put it in the proper place. And then so once done, and then so all the numbers, okay, after fifth iteration, okay, all the numbers are placed in a proper place. And then so it also similar to the bubble, but every time and then we are trying to find a largest one. Okay, you have to select a largest one that you are going to move it to the right corner. Okay, and the right corner of the sorted list. And then so okay, like that. And then so you keep on moving all the elements from unsorted list to sorted list. Okay, and then so this will also have the same kind of comparison. Okay, and then so the procedure is written here. Okay, and then so initially the list contains all the n items. Okay, and then so you have to find out the minimum or maximum, largest or shortest. And then so okay, and then so in case of shortest one, that you are moving to the left end. Okay, otherwise then it is in the right end. And then okay, so that is described and this algorithm. Then similar to that, and then the time complexity is what happens. Okay, for each comparison, it requires order of n under one iteration. Okay, and then similarly again, okay, number of iterations should be order of n. Okay, and then so at the maximum, so the order of n. So it is order of n into order of n. Actually, n minus number of one, n minus one number of comparisons alone. And then so okay, it is equivalent to okay order of n squared. And then the space used here is only one alone. So only one swapping alone, and then we are going to take. And then so the auxiliary space used here is order of one. Okay, and then so that's about selection sort. Any doubts in this?
Ma'am, no, ma'am, it is clear, ma'am.
Okay. Then the next one is insertion sort. So this is also the simplest sorting algorithm. Okay. And then in case of playing card, that should be the best example for it. And then, okay, what we are trying to do, we are going to take one card, and then so that you are going to insert it in the middle. And then, okay, and then according to our implementation part, and then it should be divided into again two. So one is sorted list, and then another one is unsorted list, and then like a selection algorithm. Okay, and then so the values from unsorted are picked. Okay, you have to take one by one from the unsorted, and then you have to place it in the proper position at the sorted. And then okay, and then so previously we are trying to take okay either smallest one or largest one. Okay, that you are going to move it to any one of the end. And then so but in case of here, so from the starting onwards, and then you have to take one number from the list. And then so but you have to properly fix it in the okay unsorted sorry sorted list. And then okay, and then so while you are placing itself is in the proper order, and then that is called as insertion. And then so you have to insert in the sorted list array. That is a concept. And then so therefore, and then we are trying to reduce the number of comparison here. So this is also a simplest implementation. Okay, simplest algorithm also. This should be efficient for only small values. And then so okay, if the list contains the smallest number of elements. Okay, the number of elements should be smaller. And then if you have large number of items, then this is not efficient. And then since and then it takes much time for it. And then okay, and then so your data set should have small number of elements. Okay, and then so sometimes, and then if it is partially sorted, and then so it will minimize the number of comparison. Yeah. So these are the steps within the algorithm. Then we are going to take all the n elements array of size n. Either you have to do it in ascending order or descending order. Okay, and then you have to iterate it from one first number to last number of the array. Then take any one current element. Okay, and then so that you have to compare it with the next element, and then so like that, and then keep on taking one by one element and do the processing. And then yeah, the previous two examples, and then I took the whole numbers. Now we have taken the list of values having the real numbers. Okay, and just to see here, then these are the set of values available in the array. Okay, so that we can call it as its positions, and then call it as index here. So zeroth position, 1, 2, 3. Okay, so in case of implementation, we can also represent it like this, and then okay, if it is in C implementation, okay, you have to start with the zeroth element. Okay, so array starts from 0, and then if you have 10 elements means, and then 10 minus 1 number of position, that is index, has to be represented, and then so that's why 0 to 9, and then okay, those are for manual processing. And then in case of actual implementation, C language can starts from array value, okay, from 0 onwards. Then so these are the actual values which are present, and then so this is in the unordered list. Okay, so initially everything will be in the unsorted list. Okay, and then so after that, and then you are what you are trying to do, okay, take each number, and then that you are going to place it in a proper position, and then okay, how to do? If you require an ascending order, first, okay, first number you just take it. Sorry. And then okay, we do not know, and then any other number in the list, and then therefore just keep it as it is. Okay, then in the next iteration we are going to take the second number. Okay, so now just compare it, and then okay, and then these two numbers, what will happen? Yeah, sorry. Yeah. Put a full screen, and then it will be convenient, since the animation is there, and then how to there, and then okay. Yeah, this is the first step. Okay, it is 0 step. So we have taken the first number, 2.08, array of 0, that is 2.78, and then the next one, so we are going to take the second number. Okay, and then consider the first and second, and then that is 0th position and first position numbers, and then okay, the first one should be the smallest one, second one will be the highest one. If not, just swap it. Okay, and then otherwise, and then okay, leave it as it is, and then so this is an insertion algorithm, and then in if it is smallest one, you are going to insert it at the 0th position, and then this will be moved to the next position like that, and then keep on moving, and then if you have some set of cards are there, and then take one card, and then which is the smallest one, okay, before that, and then you are going to insert it, and then if your number is the smallest one. Okay, and then in the next step, so you are trying to compare with next two values. Okay, now 0.56 and 7.42. Okay, so this one is the smallest one. Therefore, what you have to do, this has to be inserted before 7.42. Okay, that's why these two comparison is made, and those two numbers, okay, that is 0.56 is to be inserted, okay, before 7.42. Similarly, that should also be compared with your previous element in the list, and then now it is also compared with, okay, 2.78. Okay, it is also lesser, therefore just move it to one more position. Okay, now at the end of a second iteration, okay, so this number will be keep it in the proper place. Okay, so that is 0.56. Okay, so now the first three numbers are placed in its proper place, proper position, or proper location. Okay, and then so next, the next number has to be taken, that is 1.12, and then you compare it with previous numbers. Okay, so while comparing, so this is the smallest one, just insert it before that number. Next, this should also be compared with the previous number. Okay, so what happened? Okay, so this is the smallest one, therefore this should be inserted before this number. Okay, just move it to one more position. Okay, similarly, this should be compared with the first number, that is zeroth position. Okay, and then so while comparing, this is the smallest one, therefore there is no movement. Okay, just to keep it as it is. Now this iteration is over. Okay, and then then next, go to the next number. Okay, so that is 1.17, that is this one. In the fourth iteration, you have to process it, and then okay, so again compare it with the previous numbers. Okay, so if the specified, okay, which number you have taken, that is the smallest one, just move it, okay, before, otherwise insert it before. That is the actual concept, and then okay, then it is always be done are inserted in a proper place, and then after the complete iteration, after few steps, and then that should be moved to its proper location. Okay, so now 1.17 is taken, then just move it since it is smaller. Next, that should be compared with 2.78, and then that is also smaller, so therefore again move it. Then it is compared with 1.12, and then this number is the smallest one, just to leave it as it is. Again compare it with k 0.56, then already this one will be the least one, just to leave it as it is. Okay, and then now one iteration is over. Next, move on to the next iteration. The next number has to be taken. Okay, so the number here is 0.32. Okay, like that, and then keep on doing all such comparisons. Sorry. All such comparisons. Then finally, those numbers are inserted in its proper place. And then, so this is called as an ascending order. In case of descending order, what we have to do? Okay, just a reverse process. So reverse process means, and then those things are moved to the right end. Okay, smallest one has to be moved to the right end, and then okay, in case of ascending order, smallest one has to be moved to the left end. Okay, and then how many number of comparisons are made here? So just assume that, and then there are 10 numbers. How many comparisons are made here?
N minus 1, ma'am.
Yes, under each iteration, there are n minus 1 comparisons again. Okay, and then if there are n numbers, 10 numbers means 9 comparisons, totally 9 into 9, 81 comparisons. And then sometimes only the swapping, the movement or insertion will alone will be reduced if it is already in the order. Okay, and then that alone, and then we are trying to reduce it. And then, based on that, and then again, we are going to have the complexity as n squared. Okay, and then the actual number of comparison is n minus 1 into n minus 1 alone. But according to the complexity calculation, okay, it is made as order of n squared. Okay, again, so only one comparison is done. So therefore, only one space is enough. Okay, so the auxiliary space used here is one alone. And then, okay, so now the sorting is over. Then where are we use sorting algorithms? Sorting algorithms. Tell me any applications of sorting. Yes. Some applications of sorting. Even in the data structure, you have different kinds of data structures: stack, queue,
In binary search, ma'am,
binary searching.
the input has to be in sorted order. So
Yeah, it
if the
has to
input
be
is
in.
not in sorted order, then I have to perform any kind of sorting and I have to perform the binary search.
Okay. Yeah, tell me any kind of applications, real time application, which can make use of sorting. Yes. If you want to.
Ma'am,
Mm.
contacts list, ma'am, when you are trying to have it in ascending order.
Yes. Mm. Contact list, ascending or descending order, and then that we can keep. Mm. Okay. If you want to place the students according to height wise, that is also one of the example. Then even while you are writing thesis, and then so you have to place the references based on first author name. Okay, that should also be keep it in the alphabetical order. Okay, and then so in case of strings, and then we can say it as alphabetical order. If it is a reverse case, and then so that is called as reverse alphabetical order. Numbers alone, and then we are saying ascending or descending. Then any other queries?
And I hope they don't have any queries, ma'am. Thank you so much for the session, ma'am.
Mm. Thank you.
Ma'am, kindly, we can switch on your videos for taking photo, ma'am.
Okay.
Participants, kindly switch on your videos for taking photo. Ma'am, ma'am, I have a doubt. Ma'am, how to choose a sorting algorithm for different kinds of applications, ma'am? Given a question, how to choose which sorting technique will be efficient to execute, ma'am? Participants, kindly switch on your video for taking photo. Thank you, Usha Devi, ma'am. Thank you so much, ma'am.
Thank you all. Thank you for
Thank
patient
you.
listening. Shall I leave, ma'am?
Yes, ma'am, you can leave, ma'am.